Okay, so you can pause the video to read the word problem, but the basic idea is that we're trying to maximize profit for something. So for some reason, the LA Lakers have decided they're going to go to a high school, they're going to play a game, and we're supposed to maximize how much money that the people can make from the game. So we want to know something about the cash money. So to find out about how much money that can be made, well, we can write it down in words before we even do any of that algebra stuff first. Okay, we can say the money that they're going to make is going to be the number of tickets sold times the price per ticket. You know, this is just a basic fact. You sell 50 tickets, $40, you make $200. 70 tickets at $10, you make $700, etc., etc. So number of tickets times price, that will give us how much money we have. But now let's try to put that with some algebra using the facts that we're given. Starts off with 200 tickets. Okay, and he starts off with a price of $40. But they gave us some information to say that that could fluctuate. You know, if you increase the price by 50 cents, obviously it's going to make some people just a little less likely to go. So if you increase the price 50 cents, you lose 4 people. So there's a plus 50 in our price. There's a minus 4 for the number of people. But then if you increase the price by $1 instead, that's $1, you lose 8 people. But if you increase the price by $1.50, you'll lose 12 people. And that can keep fluctuating. That's a variable. So that's what we really need to maximize. What should that price be based on losing 4 people for every 50 cents we increase it? So we need some variables there to help us maximize. I'm just going to put the letter X next to these because the X is going to stand for the number of times we increase the price by 50 cents. You know, you put in a 2 in here, that means you've increased it $1. Put a 2 in here, that means you've lost 8 people. So it represents that change that we saw at the top there. So we have a complete expression that represents what's happening. The number of tickets is here, and it's a variable because we might change that price. And the price per ticket is here, and it's again to get a variable attached. So how are we going to maximize it? Well, first let's look at what it looks like if we were to multiply this out. And so to multiply this out, this is 2 binomials multiplying. So you could use the FOIL method, or you could use something that I've seen called the box method. The box method is pretty cool. To multiply 2 binomials, you just write the numbers in the first one up top in the box, and the numbers for the second one on the side of the box. And then you just multiply straight across. 40 times 200. And then you can do 40 times negative 4. And then to finish out the box, 200 times 50. Sorry, that's 200 times 0.5. So that's like taking half of something. And then it had an x next to it, so 100x. And then this times this. Negative 4x times 0.50x. Negative 4 times 0.5 gives you negative 2. X times x gives you x squared. So to finish out the box method, remember our goal was to multiply this out to see what it looks like. And where did that go? When you multiply that out, you get the things in red. 8,000. Oh, come on. 8,000 minus 160x plus 100x minus 2x squared. Okay, but to put that in the order of descending powers, negative 2x squared needs to come first. These guys can combine to give you negative 60x, and we have a positive 8,000 to end it off. So by boxing it out, you might think, what the heck did that do for me? And to which I would reply, it has gotten you to recognize what type of equation this is. The money, according to the information we're given, is a quadratic relationship. And if something's a quadratic, you can always maximize or minimize depending on which way the graph of the quadratic looks by using this little nifty formula. This will always give you the max and the min of a quadratic. Okay, and you should recall that A is always the number that's being multiplied in front of x squared, B is always the number that's multiplied to the x, and C is always the number hanging out by himself. So in this case, my A is negative 60. So you should see I put a positive 60 up top here because a negative gives me a positive. And then divide by 2a. Well, a is negative 2. 2 times negative 2 gives us a negative 4 down bottom. So you divide those and you'll get x equals negative 15. That doesn't mean negative $15 or anything like that. If you go back to what we started with, x represented how many times we increased the price by 50 cents. So this is actually telling us it's a negative number we're plugging in for x. We're going to be decreasing our price. So to find out what the maximum price is, we just maximized using the vertex formula. Okay, this always maximizes or minimizes a quadratic. In this case, it maximized and told us the max value occurs at x equals negative 15. So to find out the max cash money that we needed, plug in the max x value that we found, negative 15. You'll see it there in black. So when you simplify this guy, you got to do a multiplication first inside the parentheses. That's 200 minus a negative 60. So that's actually plus 60. Minus a negative is the same thing as plus. And over in this guy, 0.5 times negative 15, that means half of negative 15 when you multiply by 0.5. So that's negative 7.5. So you got 40 minus 7.5 over here. Okay, simplify a little bit more, and you get 260 times 32.5. And that's going to be your max money. 8,450 in this case. Okay, so there we are. We maximized. The maximum revenue occurs when we plug in negative 15. So our remember this represented our price. The max price occurs. Wait, this is ugly. Hold on. The max price occurs when the price is set at. The max revenue occurs when the price is $32.50. That's when we get our maximum revenue. Okay, and we expect to sell 260 tickets at that price. Okay, remember, because that's what each of these parentheses represent. This is number of tickets, and this is price.